Today we're going to talk about entire and mixed radicals. And I'm going to start out by defining what those terms mean. And then we'll talk about the relationship between the two of them. Okay? So an entire radical is basically everything that you've seen so far. It is when the entire number is written under the radical symbol. So that would be in the radicand. Okay, so for example, something like the cube root of 24. That's an entire radical. Okay. A mixed radical, on the other hand, is the product of a rational number and a radical. It means you're multiplying them together, the product. Okay, so for example, something like 2 times the cube root of 3. Usually you don't have that dot there or a multiplication sign. The dot, by the way, is a multiplication sign. That's one thing that I did notice. A couple people in that pre-assessment didn't know what the dot meant. It's another symbol for multiplication. It's usually just written as 2 cube root 3. So the implied operation is multiplication between those two numbers. Okay, so what I want you to do very quickly is just pull out your calculator and enter in cube root of 24, see what you get, and then enter in 2 times the cube root of 3 and see what you get. So you should have either a cube root button or you might see something that looks like this. Okay. No, you can for now. You can use that one.
Do I need a graphing calculator?
All right, what did you guys find? Yeah, they're the same value. Yes, okay, so these two numbers have the same value. Okay, so one thing that we know already is that radicals can be most of the time, not all of the time, but most of the time these can be written in two forms. an entire radical, and a mixed radical, okay? The mixed radical is also called the simplified radical, okay? And if you're asked to simplify a radical, what I want you to do is to convert it from an entire radical to a mixed radical, okay? A mixed radical is also sometimes called a simplified radical. So the process of simplifying a radical is to convert it from entire to mixed, okay?
So the 24 would be.
This is entire.
Okay.
This is a mixed radical or the simplified version of this one. Okay, we're going to do more on that later. Don't worry. Okay. Today our goal is to learn how to convert between the two. So go either way, entire to mixed or mixed to entire. To do that, we're going to do a little bit of an investigation here. So I want to evaluate a bunch of different things. All right. Let's look at this one. Square root of 4 times the square root of 9. So without your calculators, how would you do that? Yeah.
Get like the answer to those.
Okay, so the answer to square root of 4, 2 times 3, and that is 6. Okay? What about this guy? What do you have to do first here? Yeah.
You multiply the two together, then square root.
Right. You multiply 4 times 9 first. So 4 times 9 is 36. And you take the square root of that. And that is also 6. Okay? 16 times 9. So, square root of 16 rather times the square root of 9. What's the square root of 16? 4 times 3. And that's 12. Okay. What about this one? Yeah. Yeah. So what's 16 times 9? 144. And the square root of 144? 12. All right. Okay. Here we're going to divide a couple of radicals. So the square root of 36, 6 over the square root of 9, 3. 6 over 3 is 2. And here we have to divide 36 by 9 first. So 36 divided by 9? 4. Square root of 4, rather. And that's 2. Okay? And then finally, these last two, the square root of 100, 10 over the square root of 25, 5. And that's 10 over 5 is 2 as well. And then what's 100 divided by 25? 4. So this is the square root of 4, which, surprise, surprise, is also 2. Okay? So it looks like we can actually take something like the square root of 36 and break it up into the product of two radicals. It's the same as the square root of 4 times the square root of 9. Okay? So in general, if I have the square root of a times b, I can break that up into the product of two radicals where one of them is a, square root of a times the square root of b. Okay? And I can do the same thing with division. If I have the square root of a quotient, a over b, that can be written as the quotient of two separate radicals, the square root of a times the square root of, divided by, rather, the square root of b. Okay? This is going to come in really handy when we start to simplify these radicals and convert them into mixed radicals. Okay? One thing that I want to make really clear here in this generality is that the indexes must be the same. Okay? So if I have, for example, the square root of a over the cube root of b, I can't do that. I can only write it as a single radical or even split it up into two if the indexes are the same. So if everything's square roots, that's fine. If everything's cube roots, that's fine. If everything's fourth roots, that's fine. I can't mix and match. Okay? All right, I also want to talk a little bit about squaring a radical. So if I take the square root of 2 and I square it, what do you think I'm going to get? That's right. Yeah, because remember, these two things undo each other. So if I take a square root of something and then square it, I get back to the radicand. But even more so, based on what we just saw above, Square root of 2 squared is the same as the square root of 2 times the square root of 2. That's what it means to square something. You multiply it by itself. Well, we can write that as a single radical. It's the square root of 4. Because remember, this times this gives you the new radicand. Square root of 4 is 2. So this is 2. What's this one going to be? 3, 4, 9, 10, 25. Okay? And similarly, so this is a generality. The square root of x squared is x. More generally, the nth root of x to the n is equal to x, right? So this applies to higher roots. If I take the 4th root of 5 to the 4, I get back to 5. Okay? All right. Now we're going to use all of this stuff to start to learn how to simplify some radicals. Actually, first, so we're not going to go through this whole thing, but the point of this little exercise, we already actually did it in the middle one, was to show you that these, the numbers in each row are equivalent, right? So you guys did the cube root of 24. What was that?
It was like 2.88.
2 point, say that again?
8844991141.
Okay, and this one? Same, yeah. 449, it keeps going, right? Yeah, so these are equivalent. And it turns out that these are all equivalent. Now, just to review how to find that button on your calculator, I'm noticing most of you guys have scientific calculators at this point, which is fine. All scientific calculators, though, will have a button. Usually you have to hit the shift button first that looks like this. Okay, it's not the square root or the cube root, but there's specifically an x in there. And this is the one that you can use for any root you want, right? So any index you want. You do have to put the index in first, though. On the TIs, where did that calculator go? There we go. You have to enter the index in first, and then that button is under math, and you have to go down to 5. So on the TIs, you don't use the shift button. It's in the math menu. And then you could put in 405. And this is 4.486. And then if we do the other one, which is 3/4 root of 5. Okay, so 3 times, again, I put the index in first, 4. And then I'm going to hit the math button and go down to number 5. And if you have a scientific calculator, you'd have to put the index button in, then usually use the shift button to find that x root. And this is 5. And we can see it's exactly the same. Okay? The top line is the same as well. So this is what, 4.486? It keeps going. Okay, so these are also equivalent. These also happen to be equivalent. Okay, so what we need to do is figure out how this all works. And we are going to use some of the things we learned on the previous page to do so, as well as some of the stuff that we talked about yesterday. So I actually, because I want to write out all of the steps, I'm just going to pull up a new page, and then we'll come back here in a second. We'll use the first one as an example. So let's say I asked you to simplify the square root of 80. I could also ask you to write the square root of 80 as a mixed radical in simplest form. I think that's actually the instructions that I gave. Okay? There's 2 ways to do this. The first way is to write 80 as the product of 2 numbers where one of them is a perfect square. Okay, so if you go back to the very very front of your booklet, you have a list of all of your perfect squares, 1, 4, 9, 16, 25, 36, 49, etc. And what we want to do is say, okay, could I write 80 as the product of two numbers? So multiply two numbers together to get 80. But one of them has to be a perfect square. Yes. Okay, how would we do that? Yeah.
4 times 20 because 4 is a
Yeah, I could write it as 4 times 20. Okay? So let's try that. So instead of writing the square root of 80, I'm going to write it as the square root of 4 times 20. Okay? Now, I'm allowed to break this up. We just saw that on the previous page. I can actually write this as the product of two radicals. Square root of 4 times the square root of 20 has the same value. What is the square root of 4? 2. There you go. So now I have a mixed radical. Am I done? Do you think I'm done? That's a loaded question. If I ask it like that, I'm probably not done. Yes?
You have to square the 20.
I have to square the 20. If I squared the 20, though, then I'd be changing the value of this number. I'll give you a hint. You have to ask the same question. Can you write 20 as the product of two numbers where one of them is a perfect square? Yeah, what can you write it as? 2 times 10, that's
prime number.
right, yeah. So
But
here
it's
we need to.
also a perfect square, though. No, it's not.
All right, so is there a perfect square factor of 20? Yes. 4. Yeah. So I can write this as 2 times the square root of 4 times 5. And then I can break this down further. So 2 times the square root of 4 times the square root of 5. And the square root of 4, of course, again, is 2. So this is 2 times the square root of 5, which is 4 root 5. Okay. Would it be possible to do this in one step?
Probably.
Instead of 2? What would you have to do differently in this first step if you wanted to do it in one step instead of 2? I asked you to write 80 as the product of two numbers where one of them is a perfect square. Is there another way of doing it? Instead of writing 4 times 20, is there another perfect square that will work? Go look at your list of perfect squares, see if any of the other perfect squares are factors of 80. $16, that's right, and that's a bigger one. So you can also do it this way. The square root of 80 is equal to the square root of 16 times 5. You can break that up too. Square root of 16 times the square root of 5, and the square root of 16 is 4. Okay, if I asked you to write this in simplest form, and you stopped at 2 root 20, that would not give you full marks, because this is not in simplest form. If you keep going and do it in 2 steps, that's totally fine. Okay, but what you want to actually do is you want to look for the largest perfect square that's a factor of your radicand, if you want to do it in one step. Okay, so for the largest perfect square, that will work. Okay? This is one method. I only use this method if I can do it immediately in my head and I know 16 times 5, boom. If I have to do more work than that, I don't use this method. And instead, I use prime factorization. Okay, so that's the second strategy that you can use. Okay, so the first thing we're going to do here is prime factorize radicand. Okay, so that's the 80 in this case. So I'm going to look at 80, and I think I'm trying to like brainwash you guys into using the tree method. I think that's going to, no, I'm just kidding. Okay, so what can I'm going to start with my smallest prime, which is 2. Can I divide 80 by 2?
Yes.
Yep, so that's 40. Oh my goodness, what is going on here?
That's a pretty cool too, though.
Yeah. Okay, so that's 40. Can I divide 40 by 2? Yep. 20, and I can keep going. 20 divided by 2 is 10, and I can keep going again. 10 divided by 2 is 5. And now I'm going to stop because 5 is prime. Okay, so that's the first thing I want to do. And I'm going to actually write this out, the square root of 80. This is kind of key, okay? So the prime factorization is great, but you also actually explicitly want to do this. Okay? I find when people don't do that step where they actually write the entire prime factorization under the radical sign, sometimes people get confused. Okay? The next thing you're going to do is you are going to see if you can find any pairs of primes. And every time you see a pair, okay, so here I have 2 pairs. Every time you see a pair, you can pull one of them outside of the radical symbol. And the reason for that is because the square root of 2 times 2 is the same as the square root of 2 times the square root of 2. Square root of 2 times the square root of 2 is 2. Okay, so every time you see a pair, pull one of them out. Okay, so pull one pair from each prime out of the radical, and what you're going to get is 1, 2, because there's one pair of 2s, and then another 2, because there's another pair, and then what's left over is anything that doesn't pair up, and that's the 5. So this is going to be 2 times 2 is 4 square root of 5. Yes?
Is it one prime from each pair or one pair from each prime?
So if you have a pair of primes, you pull one of them out. Pull one prime from each pair out of the radical. So if you've got primes that pair up, one of them can come out. Is that okay? Yeah? Okay. And you end up with 4 root 5. Okay. Questions so far? Yes?
So is it up to you then which method you
Yes, you can use either method. The one thing that I will say, though, about prime factorization is that next year, particularly if you go into the -1 stream, you're going to be simplifying algebraic radicals. And so if you're simplifying like the square root of 50a cubed, for example, the a cubed part isn't going to show up on your list of perfect squares, but you can actually use the same strategy as prime factorization to do the same thing. So I would be familiar with both, although you can choose. Okay? All right. So I'm going to go back. We're going to try a couple more. Okay? So when I'm looking at b, the cube root of 144, so if I use the first method, when I was looking at the square root of 80, I wanted a perfect square factor of 80. If I'm doing the cube root of 144, what do you think I'm going to be looking for here? Perfect cube factor of 144, correct. Okay, so you got to look at your list. So it goes 1, 8, 27, 64, etc. Okay? So can 144 be divided by any of those? Any of the perfect cubes? Yes. 8. Yes. So 144 divided by 8 is what? What's 144 divided by 8? Yeah. 18. Yeah. So you can write the cube root of 144, same as the cube root of 8 times 18. And then you can split this up. Cube root of 8 times the cube root of 18. And in fact, if you want to leave the first line and go down to the second line, that's fine too. Okay? And then, of course, the cube root of 8 is 2. Okay, so that's method 1. If we use the second method, I'm not going to use both methods for all of these. We have to take a look at the prime factorization of 144. So I'll start with 144, and I'm going to just exhaust my 2's as much as I can. So that's even. When I divide that by 2, I get 72. Okay, and then I can keep going. 36 divided by 2 is 18, and I keep going. 18 divided by 2 is 9, and then I get 3 and 3. Okay, so again, take the step of actually writing out the full prime factorization in the radical symbol. So this is 1, 2, 3, 4 2's, 2 times 2 times 2 times 2, and then 2 3's. Okay. Now, when I was looking at square roots, I wanted pairs of primes. For cube roots, what do you think I'm going to be looking for? Groups of 3. Groups of 3, exactly. Okay? And I do have one group of 3. There's a group of 3 2's. So one of them can be brought out. And then what's left up is a 2 and 2 3's. Okay, and then you should multiply those all out. So 2 times 3 is 6, times 3 again is 18. Okay, all right, so we're going to try a couple more, and then I'm going to get you guys to try some yourself. I'm running out of room over here, though, so I'm going to write down below. So the next one is the 4th root of 162. And for something like this, I would just go right to prime factorization personally, because I don't tend to, I could probably do this one in my head, but I don't tend to memorize my 4th powers. So I'm going to skip the, writing it as a 4th power times something else and go straight to prime factorization. Okay, so this is even. So I can divide it by 2, and I get 81. Okay, now what? Can't use 2 anymore. What can I do next? Yep.
9.
Okay, so I could do 9, but if you're using the ladder, these guys have to be. So if you're going to do 9, break it into 2 9's, use the tree. Yep. 3, yeah. And you get 27. Okay, I'll show you the tree for this one too so that you can use either. And then again, 3, 9, and then 3 and 3. So really important, if you're going to gravitate towards the ladder, the most important thing is that everything on the left must be prime. You don't have to go in order. You could start by dividing by 3 first, but you can't have any composite numbers on the left. Okay, if you want to do a tree though, then it doesn't matter, right? So you could break that into 2 and 81, and then the 81 into 9 and 9, and then have your 3's, right? Yes? Mm-hmm. Yeah, since it's a 4th root, you're going to look for groups of 4. So this is 2 times 1, 2, 3, 4 threes. Yeah, it's a fourth root, so we need groups of 4. And we have a group of 4 threes. So one of these can come out, and this is going to be 3 fourth root of the only thing that's left over is the 2. Yep. All right, and then 2 more, and then I'm going to get you guys to try some yourself, okay? So the next one is -3 square root 60. Okay. So sometimes people get confused by something like this because it's already a mixed radical, okay? But it's not simplified. So to simplify it, we actually have to just work on the square root of 60. And then the whole thing gets multiplied by -3. Okay, because this guy probably has a perfect square factor in it. Okay, so I'm going to work on this 60. So I can divide that by 2, and I get 30. And I can divide that by 2 again, and I get 15. And then this is 3 times 5. Okay, so essentially what I have here is -3 times the square root of 2 times 2 times 3 times 5. Yep. Yeah, you take pairs out of this one because it's a square root, right? And there's a pair of 2's. So I can pull one of these 2's out. And what that gives me, I still have this -3, so -3 times 2 times the square root of what's left over is 3 times 5. Okay, and then of course you would multiply the numbers on the outside and the numbers inside the radicand, or the radical symbol together. So this would be -6 root 15. Yeah.
So if you were doing cube roots,
Mm-hmm.
instead of looking for pairs, would you look for roots of 3?
Yep.
And then just take one away.
Correct. Yep. And then finally, the last one is the square root of 26. So if I look at the prime factorization of this is even, so I can divide that by 2 and I get 13. Now what? Yeah.
So, at the end of it, if you have like 2 numbers in the symbol, you multiply them together, right?
Yep. Yep. Okay, so can I keep going here? Yeah? No, 13's prime, that's right. So this is the square root of 2 times 13. All right, what do you think we can do here? What do you think? Yeah, there's nothing we can do, right? This is fully simplified. If there's no pairs of primes and you're taking the square root, then your radical has already been simplified. So here there are no pairs. Or you can also think 13 doesn't have any perfect square factors. None of the perfect squares divide evenly into 26. So this is fully simplified. Right? So you just write it. The square root of 26, or you'd write fully simplified. Okay, any questions on that? Yeah. Yeah. Okay, so what I want you guys to do now is to work on these ones. Okay? Just give me one sec. Why Why do I not remember how to pause this thing? All right, I'm just going to stop it, and then I'll slice these together. Class, what we're going to do is learn how to go the other way. And the other way is actually quite a bit easier. So what if we have a mixed radical rather, and we want an entire radical? And what you want to think about when you're doing this is, what if I had been simplifying? So here I have 4 times the square root of 3. How many groups of 4 would have had to be under the radical symbol so that I could pull one out? 2. Yeah, I would have had to have two 4s rather under this radical symbol to pull one out. So if I'm putting it back in, I got to put back in 2. And then of course, I would want to see you multiply that all out. So what is 3 times 4 times 4? Well, it's 12 times 4 is 48. Okay, when I'm simplifying this one, 3 times the cube root of 2, how many 3's would have been in the radical symbol to pull one out? 3, yeah, so I'm going to put 3 back in. 1, 2, 3, and then multiply that all together. Okay, so 3 times 3 times 3 is 27. 27 times 2 is 54. And of course, like, I'm doing this in my head, but you could do it on a calculator for sure. Okay, and then finally, this last one, 2 times the 5th root of 2. How many 2's would have been under the radical symbol to pull one out? 5, and I have another one as well that's still left there. So altogether, there would be 6. Because this is the one that's left, right? And then there's 5 more so that one got pulled out. Right, so this is the group that got pulled out. And that, I believe, is 64. Because 2 to the 6 is 64. But again, you can use a calculator for that. By the way, if I was doing this on a calculator, I personally would enter it into the calculator in exponential form. Instead of multiplying 2 together 6 times, I would write 2, use my exponent button, 6. And then it's just faster. Okay? All right, so I'm going to get you guys to try these 3. And that will be it for today. What I would like, a couple things. So number 1. I have actually scheduled tomorrow's class to work on the same concept as well, because it's a bit of a long lesson. So what I want you guys to do tonight is to work on this next page, which is just on simplifying radicals. Okay? I want them to be simplified. So something like this one that's already a mixed radical, don't give me the entire, simplify it further. Okay? And then in class tomorrow, we'll have time to work on the rest of the homework. All right?